So if n equals is less than equals to and n is greater than or equal to 0. So this one is just using the reverse mode. They still the same thing as saying if n is greater than equal to 0 and n is less than equal to 15, right? So okay, so we can now have our for loop like we did before, right? So let me just put it side by side. For loop, right? And then I'll say for with after this guy I'm supposed to bring this guy down. Anyway, let's see. It's going to ask me to bring this guy down, but I'm trying to manage space. Anyway, so if for n is a digit, right? For n is for digit equals to 0 and digit is less than equal to n, digit plus plus, this one will have its own parentheses. So this is like basically what I was doing before, and then but this time around we're going under dimension. So let me just code along and see if this works, right? And close parentheses. And inside we should have a for loop. For multi equals to 1, multi is less than equal to n, multi plus plus. Then we have our parentheses, and inside I have my two put char underscore put char underscore put char. This one will be comma. This one will be space. Okay, and then we have our results. Trying to see this other way to solve this. Will be digits times, as we all know, times multi, right? Then we have an if statement inside. If result is less than equal to 99 and put char, if result is less than equal to 99, then it should print. So all these concepts are what I explained before, but we're using kind of another dimension. I need to just write everything. And then if okay, this space there, if the result is less than or equal to 9. That's a single digit, right? Then you should just print only space as well. Then underscore picture space. So let me just clean this one. Okay, because we need the space, as many space as we can. Okay, so if the result, I'm using different if, I'm supposed to be using else if the result is greater than or equal to 100, then it should print then it should print this and then print this. So we should print the result divided by result divided by 100, and then we are converting it to ASCII. Because we are converting it, we put this on in brackets. Okay, and then this one, if the result is divided by 10, no, to get the second number, and then we'll do modulus 10, and then we'll convert it to, right? And then this one will be in a bracket with everyone, and this one too will be in a bracket with everyone. So we have this, and this one will have two brackets, right? Good. Okay, what else? Then let's close our parentheses. Look, I think our parenthesis is closed already. So else if, right, if the result is less than or equal to 99 and result is greater than or equal to 10, then the underscore put print the results divided by 10, print result divided by 10, and then we'll convert, and then we'll put this one in brackets. Right, and what else? Come here, and then we'll print a new line under. Why didn't I put this guy here? So a new line needs to be printed here. Okay, let me see how many number we've done. So this is 34 numbers. Okay, let's see. Man, we're gonna have so many errors, man. So let's see. Betty 100 times David.c. Please we got before the okay. I think with this two error we can still meet up. So missing a blank line after declaration. Let me see. That's number 9 and number 10. There's a space. Okay, 9 and 10. Let's see. Let's go to number 9. Number 9. Let me see which space are we missing. Okay. Yeah. And then number 10, which should be number 11 now. Let me see. Did we miss anything here? I'm not sure we missed anything here. Let's check again. Betty. Number 11, space required before the open parenthesis. Number 11. Okay, let's set number. Number 11. Okay, yes, there's supposed to be space here. Okay. So let's clear the screen and Betty again. So Betty said we are good, but we are not. We don't know if it will work. So let's first. What's going on? Okay, so let's first. Can I close this guy? Compile it and see. Alright. Let's try to copy. So we have our main dots. So we have so many errors. So the first error is this one does not have a number 13, number 14. What happened to this for loop? Let's first do them one by one. Number 13, in which MELT. Okay, MELT and is that, and then what happened to this one? So we didn't. Are you trying to say we didn't use MELT and we didn't use results? Let's first fix 13, right? So so 13. Let's set numbers. Number 13. This one's supposed to have this true. Yes. Okay, I said malt here and I said malt here. So it's supposed to be malt. And then this one's supposed to be malt. Right? And then did I say multi somewhere else? Okay. And then results. For the results, didn't I use results? I used results. Okay, let's check again. Let's clear it. Let's recompile it. So we only have one error left. Digit. Number 18. Digits. I wrote gigit. So let's check again. Number 18. Number 18, where is it? Yes. It's supposed to be digits. the compiler is smart. Oh. Okay, so let's see again. Yeah, so it worked. So let's see again. So we want to check for 100 times table. Let me clear the screen. Okay, so many errors. So many errors. I think what we didn't do right is 0, comma, comma. They were not printing on a straight line. Okay, so I think that's what we didn't do right. Except that, yes, that might be the error that we're facing. So VI 100 times table.c. VI 100 times table.c. Did I just VI rubbish? Wait, I just VI rubbish. 100 VI. Remove 100 VI. I said VI 100 times table.c. Uh-huh. So far for this one, we have a int digits. If this one, let me see, 4 digits, put char 0 for mount, cos more, mount greater than put char, comma, put char result digit times mount if result equals less than equals to then put char space if result is less than equal to 9, put char space. So this is greater than equal to 0, put char result 100 rows this future result else if result is less than 1 result is this and then future result of 0. Okay, I think we fucked up here. There's something here. I'm supposed to have something here. Okay, so let me see. Result is, so let me close this and say result if result modulus 10 plus 0, convert it. Close this. Close this. I know there's still one error somewhere. There's still one error somewhere. Let's just try this. Let me put my new line. Let me compile. Let me execute. So seems like it works, right? It worked. Okay, let me clear. So let me git add that one I just did 100 times table dot c, and then git commit it and say print random, print n times table, and then git push. Right? So let's check, and then we come down, and then we check our code. So this one worked. Okay. So the explanation, probably I'm going to be explaining the live class because there are still a lot of things I need to do. Okay. So yeah, I think this one worked. So the two worked though. That first one was very easy for me, and it's but it was just too long. So yeah. Okay, in this task we are to do task 14, number 13, and it said if we list all the natural numbers below 10. Okay, so when we list all the natural numbers below 10 that are multiple of 3 or 5, we get 3, 5, 6, and 9. Why? Multiple of 3 and 5, because 5 can only divide 5, and then they can divide 6 and 9, but 3 can still go in 6 and 9, right? We'll get this number. Okay, right? So if we divide numbers that can go um, in 10, how many numbers can go in, how many 3 can we see? Like what are the divisors of 3 that we can see, and what are the divisors of 5? It's just this 4 number. So the sum of these multiple is 23. So write a program that will compute the and print the sum of all the multiple of 3 and 5 that is below this one. So that's going to be very large, right? So you are not followed by a new line. You are allowed to use the standard library. So this will make it simple for us. So we'll copy. We don't have anything to test because we're using standard library, right? And then we don't have a prototype, so give it a main, and then we can execute our stuff ourselves, right? So we can check how it works. Okay, so we'll go here. Let me clear my screen, and then I'll vi the number, control v, and then I will include my stdio.h, right? Then I will do my commenting, and it's going to be my main this time, and I'll say probably an entry point, right? And then I'll give my return value because it's going to return an integer, which is that number. So I will just give it 0. Okay, and then I can end it here. Okay, so we have our int main, and then we don't have any argument, then we can call it void, right? Any parameter. So do like this. So the next thing is we initialize an int, right? So we initialize an int. Okay, so int I, and then we can have a sum to give us the sum of numbers. I will give both of them a 0. Okay, so the next thing I'm going to do is I'll write a little loop. I'll say for, right, and then I is what is equal to 0. As long as I equals to 0, okay, and then I is less than 1024, so our I would only go from 0 to 1024, right? And then I plus plus. Okay, so we've first done one loop, so we have to give it a condition of divisor of 5 and 3. So we'll put that inside our curly braces, right? So that's where we'll put it. So we'll now give it that condition. So if, then we'll create our braces, and then yes, we can just stop here. So if I divise divided by 5, right, is equal to 0, is equal to 0. So anything, if it is if the number I, that's the I that is generated, can divide by 5 and equal to 0, and if I can divide by 3, it means that it is a divisor of what's of what's it called, of that particular number, right? So we'll just do like this, and then we open brackets. Let me put this one in a bracket on its own. If it's this, and or because it's any of the two, and will have just be if we are looking for the two, or if, let me put it in the bracket, sorry, or if I modulus 3 is equal to 0, right, then you should sum. You can put this in a curly braces. Okay, so our sum will now be equals to what? Our sum will be equals to I plus. So we can say sum equals to 0 plus 1, or I plus 1, or I plus, let me see, sum equals to, I think plus equals to I. Okay, so this one is really saying, let me see, if this thing is true, so add I to sum. So the value of I will be added to sum. Okay, so that's what that place says. And then after that, we'll print f. We can use it to print um, value of sum, right? Then once we are done, it should print psmd comma sum, print sum, and it like this, and then we have, should return 0. But I think we have a new line, so we can put the new line here, right? Backslash n, right? So that's that, and yes. Okay, so let's git add. So first, let's betty it. Betty 101. Let's say we are good. Let me see if I can compile it to see if I'll get a compiler here. Okay, it worked. ls, let me say a dot out. We have 244293. Anyway, I don't know. Okay, that's the total of it. Okay, so let's see. Um, so what do we do? So we git add and git commit, and this one will say um, divi sum of divisor of 3 and 5, and git push. Hey, did I just add everything? Jeez, jeez. I didn't want to add all these guys. Damn, I was distracted. Oh, oh, damn. I know what to do. ls, let me remove a dot out, remove 100 times table, remove 0. Which one do I want to remove again? 100 main dot c, 100 dash main dot c, and then a dot out on 101 natural, 101 natural dot c. No, 101 is the one I did now, so I'm not removing it. And then you should remove 100, right? So let's remove everything like that. So let me git add again, and then git commit. So let me use that my old commit. Here I've deleted everything, and then git push. Good. Clear ls. Okay, good. So let's check our code. So after this, if it works, then you have three more to go. These questions are too much, man. So it worked. So see you in the next one. So in this lesson, we have to print lesson 15 or 30, 15 number 14. So in computer class, the first assignment was to write a program to print the first 100 Fibonacci numbers, right? And then instead, I wrote a program that would steal password of students. You're a thief. My teacher gave me an A. Really? Hmm. Okay. So anyway, write a program that prints the first 50 Fibonacci numbers. So Fibonacci numbers are just numbers where the previous one and the next one is added together to get the next one. So the next number after 1 and 2 is 1 plus 2, which is 3. And then the next one after 3 will be 2 plus 3, which will be 5. So there will be no 4 here. Okay. So Fibonacci number is just adding the previous ones together in order to get the next one. So the number must be separated by a comma followed by a space. You are allowed to use standard library, so we can use standard library. So let's just copy this guy, and then we vi into it. So vi file name, right? And then and then we include stdio.h, right? So after that, we write our description, kind of, and then this one will give it a main. Let me just call the main entry point because I don't want to be writing story. Okay, and then will it return? Yes, it should return because it's returning a Fibonacci number, right? So the return should be probably 0, and then let's end it here. So we'll have our int main, and then we are not passing it any parameter, so it will be void, and then we'll enter our curly braces, and then here. Okay, so let's start it. So first one is we want to save a variable to loop through because we'll be looping through. Okay, and then we'll want to declare a long int because at the end of the day it's going to be taking a lot of space, right? And then let me call it Fibonacci. So I'll create an array of integer. Okay, array will be like this, and then I won't declare it, but I'll give it to be able to store about 50 different integers, right? Okay, so we'll use this array to kind of loop. So the next thing we're going to do is we're going to initialize. If you check, they said write a program that's starting with 1 and 2, so it will start with 1 and 2, not it's not going to start from 0, so it will start with 1 and 2. Okay, so we'll initialize our Fibonacci, right? So this one can store up to 51 stuff, right? Because it starts from 0 to 50. Okay, so we'll first do our Fibonacci 0, right? We initialize it to be 1, right? Okay, so we'll do our Fibonacci double n double e double c rather, Fibonacci 1. So to be 2, right? Equals to 2. So what we are saying is that we are just using this thing to loop through. So this thing will continue 0, 1, 2, 3. So this one we've put the first two, okay? So it's not now left for us to put the formula and then let this thing just loop through and add everything together for us. Okay. So are we adding? No, we are just printing the numbers, so we are not adding. Yes. So the next thing we're going to do is let us print out those numbers. So print f, okay, and then semicolon, and then this, and then inside, sorry, inside this one, then we have our percent long, because long int, right? Long int, and then followed by a comma, right? And then we have percent long int, and then followed by a comma, and then a space, and then we want to initialize something here. So we say this one is storing Fibonacci, Fibonacci 0 and Fibonacci 1, right? Fibonacci 0 and then comma, and Fibonacci 1, right? Let me clear this space. So that's that for that. So let's go to the next line. So this is where we'll now loop through and write our formula inside it. So for I, we are going to use I to loop, right? And let me just do this like this, and then let me put my square brackets. So it's inside this loop that everything will be done. And then let me just, sorry, what's wrong with me? Yeah, this is what I wanted to do. And then let's just set our return. Our return value should be return 0. Okay, because I didn't want to forget. And then let me reduce this guy. Okay, okay. So and I want to put this one a bit down like this. Let me make sure there's no space here. Okay, I think there's no space. So we'll put the statement and then the loop, and then we'll put the condition for it to print, and then we'll finish it. So if we are putting the loop, we'll just say if I, as long as I, right, as long as I is equals to I equals to 2, right? So we'll continue from 2, and then I is less than 50. So this one will print up to from 2 to 50 48 numbers. So we'll have 50 now in total, right? So and then I plus plus. Okay. So the condition, we are going to put a formula and then make it print. Okay. So for the formula, we'll say Fibonacci. We'll put the I here. So the I will be incrementing here. Okay. So this I will be changing from, to start from 2 when Fibonacci 2, right? Okay. And then it will keep looping. So Fibonacci I equals to Fibonacci I minus 1. So if this one is 2, we put 2 minus 1, right? 2 minus 1, and then plus Fibonacci uh, I minus 2. I minus, what is it? I minus 2. Okay. So we'll end it like this. Okay. So this is like the formula. And what we did here is that we said In order to get the next Fibonacci, we'll subtract the previous one. So if this one is 2, for example, right, and this place is 2, 2 minus 1 is what? 1, right? Plus 2 minus 2 is 0. So our answer is going to be 1. Okay. So if this place is 3, 3 minus 1, 3 minus 1 is 2. So 2 plus um, 3 minus 2, right? 3 minus 2 is 1. So 2 plus 1 will give us 3, right? So it will keep increasing, getting the previous one from that. So when you calm down and do the math, you would get it. Okay. So that's like the formula for Fibonacci. So we'll now give it a condition and say if, and then if, put a condition, and then let me put a square bracket here, and then let's say else. Okay. Let me just, so this is all we need to finish our job. But this guy, let me put it down, right? And this guy, let me put it down, not this, right? So we can put our code in the middle. Okay. So if, let's first put the condition. Okay. So if I is now equals to 49, when we get to 49, okay, it should just print the I. It should not print it should print the last number, not print do where is it? Yes. So it will print the last number. So we'll just say once you get there, print f, print, and then this one will have double colon, percent, long decimal, right? And then a new line, right? And then you should print Fibonacci I. Okay. Else you should print Fibonacci I as well. 2 cents. I'm not sure if these guys are needed, but I think that's how I remembered it to be. Percent LD. We could try it out, but I don't want to waste our time. Probably if we were in online class, we'll be able to do all those experiments. Okay, so Corona. Do I need percent LD? Do that? Okay, so this one will not print a new line. Else, okay, I think that's the major reason why we have this if statement here. So what we are saying is once it gets to this 49th number, you should print a new line to the printf, right? But when, if not, you should just print it without the new line. Okay, so that's what we're doing. And this time you should just use comma instead. Okay, comma and a space. Okay, so and then Fibonacci I, and then remove this one. Okay, so let's see WQ. Let's bet it. Bet 102. Betty say we are good. Let's GCC 102. GCC we are good. Let's execute it. And you see one. So 1 plus 2 is what? 3. 2 plus 3 is what? 5. 3 plus 5 is what? 8. 5 plus 8 is what? 13. 8 plus 13 is what? 21. And 13 plus 21 is what? 34. So if you go here, 377 plus 610 is what? 978. So that's how Fibonacci number works. And then if you count it, so you see the end does not have a comma. and that's the last if statement that we added. Okay, so let us just git add the Fibo 102 Fibonacci.c git commit and say print Fibonacci number up to 50 and then git push. Okay, so let's see if it worked. So it worked, and so that'll be all for now. So let's go to the next question. Okay, so this one says this is the number 16th task and the number 15. It say each new term in the Fibonacci sequence is generated by adding, we know this. So by starting with 1 and 2, the first 10 terms will be 1, 2, 3. I explained this in the previous one. So by considering the time in the Fibonacci sequence whose value do not exceed 4 million, write a program that finds the and print the sum of the even value term. So what is saying that we should do we should write a program that would find and print the sum of even valued. So um 1 whose value does not, so by considering the time in Fibonacci sequence, so we will first consider the Fibonacci sequence that does not exceed 4 million. Okay, so we are going to write like consider a sequence that does start from 1 and does not exceed 4 million, and we'll see if that number is a even number. So to detect even number, we divide them by 2, right? We write a program that does that, and then once it does that, it should sum up all those numbers and then print out a new line. So we are to use standard library. Okay, so let me just really copy it. I won't really go too deep into it, but it's not a very long code, so it's something uh, we can reason with. Okay, so let's vi the code, right? So I will include my stdio.h since we can use printf and all. Okay, so I'll write my stuffs and then I'll give my main. I'll say print you should print or sum up, not print, sum up even Fibonacci up to 4 million, right? So do we have um a parameter? No. So since we don't have parameter, we have a return type to be probably 0, right? And then that should end it. So we have our int, since it's returning a number and we're not passing it an argument, so it will be void. And then we'll have our braces. So this will house our code, right? So the next thing I want to do is I want to declare a long int because 4 million is a long number. But normally int will be able to hold 4 million, but let me just give it a long int, right? And then so we're using percent %ld for printing. So we'll initiate some stuff and say I and x. Let's initialize x to be the first number, which is 1, and then comma, and then y to be equals to 2, which is the second number, and then we'll have a sum. Let's give it 0 for now. So that one will sum it. We'll be summing, and then we'll have the total sum to be equals to 0 as well. Okay, so we have our for loop, and this I is for our for loop. Okay, so our for loop is to go 50 times, right? So we have I it equals to I equals to 0 and I is less than 49 and I plus plus. Okay, okay, so we'll have that, and then at the end we'll have our return though. So let me write my return down so I don't want to forget. So I think this one should still look simple. So whatever we're going to put input here is nothing really too serious. We're just going to put a condition and say if, okay, and in that, sorry, if we now have this, so and in that condition let's just put this guy, right? So if, and then we say if our y, which is the second number, right, from y is divided by 2 will give us 0, it means that y is an even number, right? And also if our um if our y is less than or equal to 4 million, so we'll put this ones in brackets. Okay, so 4 million. Okay, so if we have this and then we say t sum, then the total sum should be equals to the total sum plus y. So what we are saying here is that we know the total sum is 0, right? So we are adding uh, y to the total sum every time this loop occurs, and we are saying that as far as y, that y, which is the next number, is um is div- we divide is divided by 2 and equals to 0, and it is in the range of that 0 to 4 million, then you should add it to this one. Okay, so that's what we are doing there. So then we'll exit and then we'll just do small declaration here, and then x plus y. So I will explain this one. S equals to y and y equals to sum. Okay, so this one, and this is all our code, right? And then this one is saying that so the sum now will now be our x plus y, we right? Okay, so while going on, our new x value, our new x value here is now going to be y, which is the previous one. Okay, and our new y value will now be sum. Okay, so this would enable, so all these ones will not need it again, so it's taking this value. Okay, so from beginning it has this value, but from here the sum is not 0 again, the sum is now x plus y, which is 3, right? Sum is now 3, and you know that we want to do 3 plus 2, right? So our x will now be 2, right, which is the previous one, and our y will now be sum, which will be 3. You understand? So basically that's it. Then we'll exit, we'll save and exit it, and then let's bet it. Betty 103. So spaces required at this place, so let's check it at number 9. Number 9, number 9, number 9. Yes, that two should have a space. Okay, so escape WQ. Let's bet it again. So Betty say we are good. So let us clear, and then sorry, I shouldn't have cleared it. So let's just compile it. GCC, where is it? What's the name again? 103. Right, so it's compiled, and let's execute it first. Okay, we didn't get any results though, probably because we didn't pass any argument to it. Okay, let's clear, and let's git add and see. Git add 103 alone, and then git commit and say Fibonacci Fibonacci sum of even of 4 million or less, and git push. So let's check now. Let's check our code and see. Okay, I think we are not done. We are not done. I just remembered, but we should be close. Yes. So if we check the error, we didn't print out it. So I remember, yeah, the output is not correct yet. So I just remembered. So VI, where is it? 103. So after we are done, we are supposed to print out that total sum, right? So so let me print it out here. So let me just enter here. Okay, so print f, right? So percent ld, I think a new line too, and then sorry, sum. So I think with this we should be able to um print something. Print f, right? So let's say again, Betty, let's Betty it. Betty says we are good, and then let's compile it. Compilation says we are nice, and then let's execute it. Execution says, so it printed out a number, right? So now let's git add, and I want to use my git add, git commit. Ouch, I've been sitting down for long. Git commit, and then git push. I'm using my previous commands. Okay, so let's clear, and then let's test again. So it should work now. You know, before it wasn't printing a number now. I was saying maybe because we didn't pass it output. It's because we didn't print it out. Okay, so it worked, and let's go to the last question. Okay, so we want to do the last task for this question, and question 17, number 16, or task 17, number 16, which is the last task for functions. So this one says we are to print 98 Fibonacci numbers. The previous ones should be printing 50, and then it says it should start with 1 and 2 followed by a new line, and then it says the number should be separated by comma followed by a space. Okay, and then you are allowed to use standard library, but you are not allowed to use other library. So you can't use GMP etc. I think those ones will make it easier. So you are not allowed to use long or malloc, which is memory allocation, and pointers and arrays and tables or structures or struct, struct, right? So we can't use all that, but we can use a single long. We can't use long. We are not allowed to add code, allowed to add code to any Fibonacci number except for 1 and 2. So basically that's it. So let's just get into it. This one, the last question is always crazy. But anyhow, we will try and see what we can do. So let's go to it. So let's vi and then let's paste, right? So now that we've started, we have to finish. So include stdio.h, since we can use a standard library, right? And then write our stuff. It's going to be a main, right? So the main, okay, this one is to find and what, and print first 98 Fibonacci numbers, right? So you're supposed starting from 1 and 2. So starting from 1 and 2 followed by a new line. So let me just start starting from 1 and 2. So our return should be or should be 0, right? So we have that. Okay. So I don't want this thing to be more than 40 lines. So let me just delete this guy, because if I add it, it's going to be like probably 41 lines the way I'm looking at it. Okay, so let's see. Right? So good. So we have our int, it's going to main, and any arguments, no, void, parentheses. Okay, so now the deal is done. So because we can't use a very long, we know that if we are printing up to 98 what's it, Fibonacci number, we are going to exceed long int. So in order to get more space, and we are not dealing with negative numbers, so we can just use unsigned long int. So this one will give us that space that it has give for sign. It will add it up to it, so it will look as if we are using long int, right? So we can just declare some variable I, and a variable j, a variable ij, a variable k. We can do j1 too, and then we can do j2 and k1, k2, j2, and then k1, and then k2. I need a semicolon, and then we go down. So we can initialize j. I think we could have initialized it into a here as well. So let me just initialize it here, so I can save some space. Or let me just go down. So our j equals to, our j is 1. So let me put space here. I don't want Betty to fight with me. And let's give k to be equal to 2, because these are the first two numbers that it's going to print, right? So we'll say print f, and then because it's long, do like this, and percent long unsigned, right? Long unsigned. Okay, and then we'll say j is to print j, so it's going to print 1, right? So 4, okay, for I is equals to, so we should have done it the other way we did it, but they said we can use array, so that's why. So for I equals to 1, I is less than 91, right? I think we want to print up to 98, right? And let me see, is it 98? Yes, I is less than 91, and then I plus plus. I think it should be even 99 or 99. I think it should be 99. Let me see. Okay. Anyway, let's see. So print F. We should print after that one. It should print comma percent LU, right? And it should print K. So it should print K. Okay. Yes. So K is equals to K plus J. Okay. K equals to K plus J. So we are saying that after 1, you should print 2. So what is now our K now? So our K will now be equals to 2 plus 1, which will give us the next one, 3, right? And then our J, it will now be what? Our J, which is this first one, will now be K, right? So it will be K minus J. We can use the formula, right? It will be this K now minus J. Okay. So what is our J1 now? Our J1 will now be J divided by, that should be 1, 2, 3, that should be 1, 2 incoming, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 billion. Okay, so it's going to be J1 is equals to J divided by 1 billion, and then J2 equals to J modulus 1 billion as well, and then K1 and K2 same thing. K1 equals to K divided by 1 billion, and K2 is equals to K modulus 1 billion. Okay, so we go to the next one. We say for loop, and then we initialize our I again. I is equals to 92. I is less than 99. I plus plus. Then our square bracket. We're almost done. After this one, we just print a new line and we return 0. Okay, so we print F, print F. So we give K1 a new number. K1 will now be K1 plus J1. J1 will now equals to K1 minus J1. like what we did here at the top. Okay, and then K2 be equals to K2 plus J2, and J2 be equals to K2 minus J2. So what are we going to print here? We're going to print, sorry, we're going to print some numbers. We're going to print comma space percent LD, right? And what is it that we want to print? We want to print a math function, which will be, oh my god, this thing has frozen. This thing has frozen, my god. What's going on? Please don't freeze. And I need to reload this guy. I think my data is about to finish. That's why. So it has frozen. Let me reload it. It's taking time to reload. Okay, it's back. So it's going to create a file that is going to be messing me up. This file. Okay, so let me vi into .104. Let me escape and quit it. So let me vi 104. Okay, this is what I'm going to do. 104.c. Let me vi into it. So to tell me I have some things, I say edit. So it's not here. So I have to quit it. I don't know what happened to mine. So let me remove the .104, or else it will not make me do my work. Vi 104 dash fibo. I think I copied it. Let me just paste it. Yeah, so I have to start from the beginning. Okay, so I'll just pause this and continue. Okay, so what I did is I restarted my system and we did it. So I completed this with percentile u k1 plus this and then this, right? And I added the printf statement to it. So let me escape, save. I'm very sure there will be so many bets because I was rushing in order to quickly uh, run this guy. Okay, so it said no. So let's compile it. 104. It compiled and a dot out. Okay, so we have some quiet number. Can you see how long the number is? Okay, only on unsigned long int can make us print this number. So probably in an online class we would kind of explain this guy. Okay, so let's clear and ls. So let me git add 104, right? And then git commit to print what Fibonacci last, right? And then git push. Okay, so we can clear this guy and let's go and check our code. So this ends our course for today. So I'll try and compile out the video and send it. So don't forget to like, subscribe, share it, and then keep up to the next one. See you. If you have any questions, let me know in the comment section. I know there's going to be a lot of questions, so feel free to ask. I'll be there to quickly reply you, and then you can also ask me on WhatsApp. And yeah, that'll be all.